Usually, when we talk about success, there's this expectation of, like, finality,
Yeah.
like crossing a finish line.
Right, yeah. You're just done.
Exactly.
Yeah.
Like you build a cabinet, you put the doors on it, it holds your plates, and you were done.
Hmm.
You don't take it apart the next day to rebuild the hinges just because you realize there might be a theoretically better way to distribute the weight of the wood.
No, I mean, if the cabinet holds the plates, the project is a success. You step back, admire the craftsmanship, and, move on to building a table.
Right. But stepping into the world of software development entirely shatters that definition of success.
Oh, absolutely.
Because in software, getting the thing to actually work is like only half the battle. We're
Yeah.
looking at a landscape where it works right now is a dangerous illusion because the environment around the code is guaranteed to change tomorrow.
Which is exactly why today we're looking at what happens after success. Our source material for this deep dive is a really fascinating glimpse into a developer's daily reality. It's an excerpt from Eng's Notes on Haskell Programming. Specifically, we're looking at part 128, which was published on May 6th, 2026. And the entire focus of this entry is refactoring.
Yeah, and Ang sets the stage by explicitly noting that the initial code for converting parsed text into an ebook is already functioning perfectly.
Right, it's doing its job.
Exactly. The text parses, the ebook generates, the machine is happy. But instead of celebrating and moving on to that metaphorical table, Ang opens up the hood again. And the mission here for today's deep dive isn't adding new features. It's about moving from making it work to making it resilient.
Yeah, because refactoring is fundamentally about anticipating change and, communicating better, both with the compiler and with future programmers who have to actually maintain the system down the line.
Right, which might even be yourself in 6 months.
Exactly. And seeing this happen step by step in Eng's notes provides this masterclass in software architecture. We can actually walk through the life cycle of a specific function called convert to ebook, starting right at the beginning, like how this function receives its inputs.
Okay, so in the original version of the code, Ang used this manual pattern matching to deconstruct the arguments coming into the function.
Right.
The code signature looks something like args path format, and then just 3 ignored blanks.
Yeah, those underscores.
Right. But in the newly refactored code, Ang completely scraps that manual deconstruction. Instead, the function simply takes the entire args object as a single entity and then, relies on accessor functions inside the body to pull out specific pieces of data only when they're needed.
And, this shift addresses a massive vulnerability in how systems evolve, because in that old code, that pattern match, it hard codes an expectation of a very specific data shape. It's basically telling the compiler, hey, I expect a structure with exactly 5 slots, and I'm going to bind the first 2 and ignore the last 3.
Which means the moment the data structure changes,
The function completely shatters.
right.
If, say, 6 months from now, the application needs to pass a 6th piece of information, like maybe a metadata tag for the ebook's author, the compiler will look at that 5-slot expectation and just throw a fatal error.
Wow.
Yeah. The code literally refuses to compile, not because the function itself even needs the new author metadata, but simply because its front door was designed to only fit a 5-slotted object.
It's just so rigid. Let me try to put a visual on this for you. Manual pattern matching is kind of like needing to brush your teeth at the airport. And instead of just reaching into your bag, you open your entire suitcase and dump everything out on the terminal floor just to find your toothbrush.
That is a great visual.
Right. You are unnecessarily exposing every single item to the environment.
Mm-hmm.
Whereas using accessor functions is like just unzipping the specific little side pocket where the toothbrush lives.
Yes.
You never expose the rest of the suitcase, and if you pack an extra pair of shoes in the main compartment later, your toothbrush retrieval method doesn't break at all.
That perfectly illustrates the mechanics of the vulnerability. And Ang notes this explicitly in the diary. The new approach makes the codebase far more resilient to inevitable future changes in that args data type.
It's just smart planning.
It really is. It's a defensive architectural move. You just assume the future will bring changing requirements, and you build a structure that absorbs that change without, causing cascading failures across the entire code base.
Okay, so the function is practically bulletproof on the way in. It won't break if the data structure changes. But taking data in safely is like only half the contract, right?
Oh, for sure.
Because if it completes its job but leaves the rest of the system in the dark about where the result is,
Yeah.
you've really just traded input fragility for output ambiguity.
Exactly.
Which brings us to the next major change Ang makes, and this one is entirely about what the function gives back to the rest of the system.
Yeah, we see a very specific, deliberate change to the return type of that convert to ebook function. So originally it returned an IO type, wrapping an either pandoc error, and then just an empty set of parentheses.
The unit type.
Right, the unit type. It essentially serves as this blank success state. The function does its work, writes the file to the hard drive, and basically returns a thumbs up, like, job done.
I did it.
Exactly. But the refactored kind changes that unit type. It now returns the either pandoc error, but with a file path.
Okay, so instead of just a thumbs up, it is actively handing back the exact coordinates, the actual file path where the new ebook was just saved.
Right. And this goes directly to how different modules in a large software system interact with each other. You really have to think about the program as a community of smaller interacting services.
Okay.
Before this change, other modules, like maybe the command line interface, would ask the converter to do its job. The converter would save the file and return that blank unit type.
Leaving the command line interface completely blind to the details of the transaction.
Totally blind.
Right, so if the CLI wanted to print a helpful message to the user, something like, success, your book is saved at this specific location, it couldn't just print it. It would have to reverse engineer the destination.
Exactly.
CLI would have to run the exact same logic that the converter used, recalculating the path based on the input file name and the requested format, just to guess where the file ended up.
And duplicating logic across different modules like that is, it's one of the fastest ways to introduce silent bugs into a system.
Oh, I bet.
Because if the converter function ever updates its naming rules, like, say, it starts appending a date stamp to the ebook files, but the CLI module isn't updated to match that new logic, the CLI will just start lying to the user about where the file is.
Because it's still guessing based on the old rules.
Exactly.
Man, we can look at this like a restaurant kitchen. The chef, who is our converter function, finishes a dish. If the chef just yells, "Done," and leaves the plate on a random counter, the waiter has to guess where it is based on what kind of dish was ordered.
Which sounds like a nightmare.
It creates a massive bottleneck. But handing back the file path is like the chef putting the plate in the exact pass window and handing the waiter a ticket with the table number. Explicit coordinates prevent the waiter from having to guess or reconstruct the chef's entire process.
Oh, I love that. And by explicitly returning the file path, Ang eliminates the guesswork and that duplicated logic entirely. The data just flows naturally from one step to the next. And as Ang points out in the source notes, this seemingly small change enables incredibly powerful downstream automation.
Right, because the caller possesses the exact coordinates of the new file, it can trigger immediate action.
Yeah.
It allows the program to instantly open the new ebook in the user's default reading application.
Yeah.
The split second it finishes compiling. Or it can pass that path directly into a logging system for enterprise auditing. You aren't forcing the next piece of the software chain to go hunting for the baton. You are placing it directly in its hand.
Exactly. So armoring the boundaries, the inputs and the outputs, that sets up a clean, reliable contract with the rest of the system. But we still have to look at the engine itself. We have to examine the internal logic.
Yes, which brings us to a moment of just brilliant self-awareness from Ang regarding a specific line of code. It's the logic used to determine that very output file name we were just talking about.
Oh, right, the one-liner.
Yeah, and compressed it into a single highly dense line. It's like a let statement, assigning the out path to a replace extension function, mapping characters to lowercase, converting the format to a string. It's just this massive chain.
It is a textbook example of code golf.
Code golf?
Yeah, where the goal is to accomplish a complex task in as few keystrokes as possible. So the logic grabs the input path, maps characters, converts formats, dynamically replaces the file extension, all chained together in a single breath.
I mean, I have to play devil's advocate here. There is an undeniable temptation when you are deep in the zone to write code exactly like this.
Oh, for sure. It feels powerful.
It feels elegant. To shrink a complex operation down to one line, you chain functions together, you utilize advanced syntax, and it runs flawlessly. But Ang explicitly calls this out in the diary, admitting that the line is, quote, a bit of a mouthful.
Right, because Ang is recognizing what we call the cleverness trap.
Okay, what's that?
Well, the compiler processes a dense one-liner and a sprawling 20-line function with the exact same speed. The machine really doesn't care. The problem is cognitive load for the human beings who have to maintain the system, because code is read by humans exponentially more often than it's written.
And usually, the human trying to decipher that clever one-liner is
Is your future self.
right. 6 months later, under the pressure of a production bug,
Yeah.
you completely lost the mental context of the gymnastics required to write it, and now you have to manually decompress that dense logic in your head just to figure out what it's even doing.
Exactly. And Aang sets a profound rule of thumb in these notes, which is if you can't explain the logic to yourself at a glance, it's usually assigned to stick to simple, multiple variables.
I love that.
Because clever code optimizes for the writer's ego in the present moment, clear code optimizes for the reader's comprehension in the future.
Wow. And Aang notes the plan for the next iteration of the code is to extract this dense path logic into a separate, dedicated helper function.
Yes.
And beyond just readability, extracting that logic provides a massive advantage for testing. Because if that path generation logic is buried deep inside the massive convert to ebook function, you can't verify it independently.
No, you really can't.
You would have to run the entire document parsing and ebook generation engine just to check if the file extension changed correctly.
It's like testing the whole engine just to check a single spark plug.
Precisely. But by extracting it into its own isolated helper function, you can write automated unit tests that feed it dummy inputs and instantly verify the output names without ever touching the actual ebook compilation logic. It just isolates the behavior so it can be proven reliable on its own.
And extracting that single line of logic for testability, that actually scales up to entire features, which we see exactly mirrored in how Aang approaches the PDF generation code later in the notes.
Right. The source material details this significant architectural shift where Aang takes all the logic related to generating a PDF and completely removes it from the main converter, placing it into a brand new function called generate PDF.
Yeah, because PDF generation is notoriously complex and just prone to edge cases. It isn't just a simple format swap. According to the notes, it involves taking the output path and the compiled document, running it through a TIPS template, which, by the way, requires explicitly decoding UTF-8 text, and then finally executing a system-level make PDF command with its own set of distinct options.
That is a lot.
It's a ton.
And leaving all of that deeper specific text decoding and templating logic inside the main convert to ebook function just pollutes the high-level flow.
Exactly.
When a developer looks at the main function, they want to understand the overarching narrative of the program. They want the summary of how an ebook is made, not the granular textbook on UTF-8 character encoding.
Right, and creating the generate PDF helper function creates a strict boundary. It keeps the main function clean, but more importantly, it establishes a dedicated quarantine zone for future modifications.
A quarantine zone, I like that.
Yeah, because if a bug appears in how fonts are rendering in the PDF template, like a year from now, the developers know exactly which isolated room to enter. They can tinker with the TIPS templates and the PDF logic without any risk of accidentally breaking the EP or HTML generation happening in the rest of the application.
This compartmentalization brings us to one of the most critical aspects of robust software design, and it ties heavily into how Aang handles the output of this new generate PDF function.
Oh, the error handling.
Yes, it's about what happens when things fail.
Right. So Aang notes a deliberate move toward more disciplined error handling. When the PDF generation fails, the code no longer crashes the application or fails silently. It utilizes Haskell's either type to return a proper Pandoc app error, specifically pattern matching the left type.
We really need to unpack how the either type operates here because it is fundamentally different from how many popular programming languages handle failures.
It really is.
In a lot of systems, if you try to generate a PDF and a font is missing, the program throws an exception. And that exception is essentially an invisible landmine. If the programmer didn't actively remember to write a try-catch block around the function, the exception just detonates at runtime, bubbling up and completely crashing the entire application server.
But the either monad in Haskell prevents that invisible detonation. As the name implies, a function returning an either type forces the result to be one of two explicit things.
Yeah.
A right value, which conventionally contains the successful result, like our file path, or a left value, which contains the error.
Which means the compiler absolutely forces the programmer, who calls generate PDF, to acknowledge the possibility of failure.
Yes.
You cannot accidentally ignore it. The program will not compile unless you write code that specifically says, here's what I will do if I receive a right success, and here's what I will do if I receive a left error.
Exactly. It forces error handling into the type signature itself. The failure state becomes a first-class citizen of the architecture rather than an afterthought. And by returning a specific pandas app error instead of just, a generic failure string, Ang is providing rich, actionable context.
It transforms the nature of a system failure entirely. Imagine a factory assembly line.
Okay.
In a poorly designed system, if a machine jams, it simply flashes a generic red light and halts the entire floor. The operator has to walk over, take the machine apart, and spend an hour diagnosing whether a gear stripped, the raw materials ran out, or a sensor simply got covered in dust.
Because the failure provides zero context.
Zero. But returning a specialized error type like pandas app error inside that left channel is like the machine printing out a highly detailed diagnostic ticket.
Oh, nice.
It stops, but it hands the operator a slip of paper that says, "Process halted because the TIPS template failed to decode a specific UTF-8 character on line 42.
That is so much better. And pattern matching the left type means the program actively reads that diagnostic ticket and routes it appropriately. It can log the exact failure for the developer, present a clean, non-technical warning to the user, and gracefully shut down that single task while keeping the rest of the application running.
It takes the inherent chaos of a runtime failure and turns it into a structured, communicative process.
It really does. And looking at the entirety of Ang's Part 128 diary entry, a profound theme emerges across all these seemingly disparate technical changes. Whether we are looking at replacing manual pattern matching with resilient accessor functions, or trading ambiguous unit types for explicit file paths, or isolating clever logic for testability, or enforcing strict error handling, it really all boils down to empathy.
Empathy for the calling function that needs the precise location of the generated file. Empathy for the user who deserves a clear error message instead of a frozen screen.
Exactly.
And, most importantly, empathy for the future maintainer who has to navigate this architecture long after the original author has moved on.
Because code is ultimately a medium of communication. It speaks to the machine, yes, but it speaks far more loudly to the people who steward the system. Ang's refactoring journey wasn't about making the code capable of generating an ebook.
It already did that.
Right. It was about fortifying the foundation so that it could survive the friction of time and changing requirements.
It fundamentally changes how we view the life cycle of a project, which brings up a detail in the source material that casts this entire discussion in a different light. Ang signs off the diary entry with a simple phrase, "Till the next post."
Yeah.
And the entry itself is labeled Part 128.
128 iterations of thought, refinement, and structural adjustment.
I mean, if refactoring is this constant, ongoing journey of anticipating change, extracting logic, and refining communication, it begs the question, does code ever truly reach a finished state?
Well, we started by comparing software to building a cabinet. You finish it and you walk away. But the reality is that software is not a static object. It is far more akin to a living garden.
A garden.
Yeah, it doesn't have a final state. It requires endless daily pruning, watering, and structural rearrangement just to survive the changing seasons and the shifting environment around it.
Because the moment you stop tending to that garden, the weeds of technical debt take over.
Absolutely.
The architecture becomes brittle, the error handling becomes opaque, and the system eventually collapses under its own rigid weight. The refactoring that Ang details in these notes, that is the pruning. It challenges us to look at the systems we build outside of code as well. Our organizational workflows, our daily habits, the processes we rely on. We often treat them like finished cabinets that we expect to stand perfectly forever simply because they worked yesterday.
But perhaps we should be treating them like gardens, constantly reevaluating their inputs, clarifying their outputs, extracting the unnecessary complexity, and preparing them for the inevitable changes that tomorrow will bring. Something for you to ponder as you examine your own working systems today. Thank you for taking this deep dive with us into the fascinating intersection of software architecture and system resilience. We hope it provided you with a new lens through which to view your own projects. Keep exploring, keep refining, and keep tending to your gardens.